So starting in this module, we are shifting our focus to looking at quantitative variables instead of categorical variables. So we're going to go over the same stuff that we did for categorical variables here first. So we're going to go first talking about how to numerically and graphically display a quantitative variable. So first, let's talk about measures of center. You've probably already heard about these measures of center. You've heard of probably the mean or the average, as well as the median. For the mean, what we do is we add up all the numbers that we have and divide by how many values there were. We're going to have two different symbols, though, to represent the mean. We're going to have y bar to represent our sample mean. So it's our statistic that we are interested in. And then we're going to have that Greek letter mu, which we saw back in the normals notes, to represent our population mean. So the only difference in these symbols is to let us know where that value came from. Did it come from everybody and is the population mean? Or did it come from just the sample we collected data on and is our sample mean? Then we can also find the median of a sample. So the median is something we define as the middle value inside a data set. Two different things could happen. One thing's going to happen if your sample size is odd, and another thing will happen if your sample size is even. If your sample size is odd, you will arrive at a single middle value. So the middle number in your ordered data set will be the median. However, if your sample size is even, if you remember doing this back in grade school or middle school, you would start crossing off at both sides, but you'd arrive at two numbers in the middle. When that happens, we take the average of the two middle values. Now, although you probably remember doing these calculations by hand, we're going to be letting StatCrunch do all of our calculations for us. Some other numerical values of interest are going to be the maximum, or what many refer to as the max, which is just your largest value. The minimum, or the min, will be your smallest value. Now, some of you may have heard of the third and first quartile before, but many of you may not have. So we label these as Q3 and Q1. Q just to stand for the quartile, and then of course the number for which one. The third quartile is the third quarter of the data. So we define this as the 75th percentile of the data. The first quartile will be the 25th percentile of the data. Which then may bring up the question of what exactly is a percentile. Percentiles get reported on many different things that you've probably already seen. For example, if you ever took a standardized test, many times you're told what percentile you achieved. Also, when children go in for checkups and they have their height and weight calculated, often they're also told their percentile. A generic way we were going to write this is as the kth percentile. So the kth percentile will have k% of the data below it. So for example, my son is at the 95th percentile for his height for boys his age. That would mean that 95% of the boys his age are shorter than he is. So now going back and talking about the 75th percentile, we'll have 75% of the data below it, and the first quartile will have 25% of the data below it. This often will bring up a question, though, of, well, where is the second quartile? Well, the second quartile actually already has its own special name. That's what the median is, right? So the median, being the middle value, is also what we would refer to as being the 50th percentile because half of the data will be below it. There are 5 numbers that are going to be used to create a box plot in our next video. So I'm going to go ahead and list those 5 values here. The 5 values that we need to construct a box plot are the minimum value, the first quartile, the median, or so think of it as the second quartile, the third quartile, and the maximum value. But what these values do is really cut our data into these 4 main spots. So from here to here, there's 25% of the data. From here to here, there's also 25% of the data. From here to here is also 25%. And finally, between those 2 values is also 25%. So the reason why these 5 numbers are used is that 25% of the data falls between each of those values as we go. So that wraps up the center and other numerical summaries that we might be looking at here. In the next video, we'll discuss some other measures called spread.